Hello everyone, this is a tutorial to the PulseLab GUI. In this tutorial, I'm going to talk about how to prepare database to be loaded and used in PostLab, how to do individual blood pressure fitting for each subject, how to do overall fitting using merged results from multiple subjects in the database, and finally, how to add customized algorithms in PostLab. We start by introducing how to prepare the database. Your database should be organized in one main folder with multiple subfolders. Here, we call this main folder a database and each subfolder a dataset. PostLab treats each dataset as containing synced physiological signals recorded from one subject and applies subject-specific model calibration to fit the extracted PAT values to reference SBP and DBP values. Each of your dataset folder should include some synced physiological recordings, such as ECG, fingertip PPG, and earlobe PPG in this demonstration. In addition, a file named dataset should also be included in the folder, which contains the reference blood pressure values and the time instances that they have been taken. Each of the synced physiological recording should contain a variable named signal, which is a MATLAB matrix containing two columns, with the first column being the timestamps and the second column being the signal amplitude. Your dataset file should contain a variable named subject, which has three fields: BP time, SBP, and DBP. BP time is the time instances that the reference blood pressure values have been taken, which should exist in the timestamps included in your physiological signals. The SBP and DBP field contains the corresponding reference SBP and DBP values. These three fields should be row vectors with same length. As you repeat your experiment procedures on multiple subjects, you organize multiple dataset folders and finally forms a database. In this example, we have 18 datasets in the database. Next, we introduce how to load a dataset to the PostLab GUI and do subject-specific blood pressure fitting. After you have added your PostLab working folder to the MATLAB path, type PostLab in the command window to start the GUI. Locate your database main folder, and PostLab will list all available datasets in your database. Select one of them and click Create New. The status should show New blank setting created. Select your signal files and click Add to include them in the PostLab GUI. Once you have added any signal, the reference blood pressures and the instances of measuring them are automatically loaded to the GUI and are displayed in the table on the right. The GUI will by default select a 20-second segment of loaded physiological signals around each instance and extract PAT values from this segment, assuming that these PAT values correspond to the reference SBP and DBP values measured at that instance. The segment is located from 10 seconds before the instance and 10 seconds after the instance, and can be modified at interval position. Select a whole row of the reference BP table, and GUI will display the entire recording of the physiological signal selected on the left. The red and blue vertical lines mark the start and end of each 20-second segment. Select a column of the table, and GUI displays the 20-second segment corresponding to the pair of reference SBP and DBP in that column for PAT extraction. FFT amplitudes of the selected signal will be shown on the right figure. Select another signal on the left, and the GUI switches to that signal. We can apply filters to process the loaded signal. Select a signal from the added signal list to apply filter. Select a method for filtering. Enter the required parameters and click Apply. To remove the filtering step we just applied, click Reset. Filters can be individually applied to each signal. Once the signals are ready, select a segment in the reference BP's table and go to the peak detection and PAT extraction tab. The GUI has divided this 20-second segment into 10 2-second windows. Here, signal 1 is the proximal signal. Signal 2 is the distal signal. So we change signal 2 to fingertip PPG. Drag the slider to browse through all windows in the segment. Signal quality indexes, or SQIs, can be applied to each signal to exclude windows with poor quality from extracting PATs. Select an SQI and enter the low and high threshold as accept range. You can add more than one SQI for each signal. A signal will be accepted when all SQIs are within the selected range. A window is accepted for PAT extraction when both the proximal and distal signals are accepted. Next, we locate ECG R peak and PPG maximum slope for PAT extraction. Select ECG R peak for ECG and enter required parameters, and confirm the peaks in the signal 1 plot. Repeat the same procedure for the PPG signal. Once both characteristic points are ready, the PAT values are automatically calculated. We obtained 2 PATs from the current window, as listed in Extracted Window PAT. As we move the slider to inspect the other windows, the PAT values extracted from the other windows will be displayed. All PAT values extracted from the current segment are listed as Selected PAT. A histogram is drawn from all PAT values extracted from this segment. The green bars are the distribution of PATs extracted from the current window. We can exclude outlier PAT values by averaging or applying thresholds. This is applied on all PATs extracted from the segment. For example, we first remove minimum and maximum PAT values in this segment, then take the average value from the remaining as the PAT selected for this segment. Now, all extracted PATs are shown as blue bars in the histogram, and the selected PAT is shown as a purple bar. As soon as we obtain PAT values, we can fit them to the reference BP values. Go to the red panel, select a PAT BP model, and click Evaluate and Plot. All previous settings will be applied to all segments in the loaded dataset to extract PAT values, and the selected model will be used to do regression between PAT values and SBP, and between PAT values and DBP individually. The blood pressure values estimated from PAT and the reference blood pressure values will be plotted as regression plot, Bland-Altman plot, and a BP variation figure that plots reference and estimated BP values over their sequential occurrence. Regression metrics such as mean error, standard deviation of error, and mean absolute error are also calculated. We move on to explain overall blood pressure fitting. In the File Output tab, we can save our previous configurations of the loaded dataset to a file. This file has 2 uses. First, the GUI can load this file to restore previous analysis. Second, the GUI uses this file to do BP regression over the entire database. Once we have loaded and saved configurations for all datasets in the database, we save them to the same folder in the work root, with each configuration corresponding to a dataset. Then, we add them in the Overall BP Fitting tab for an overall analysis in the database. The GUI treats each loaded dataset as a different subject, do a train test split on each dataset, calibrate the selected model subject-specifically with the training sets, and display the merged testing results as regression plots and metrics. We can also compare results from a dataset against the whole database by selecting individual subjects on the right. If we change the mode from split to regression, then for each dataset, both the training set and the testing set will be the whole dataset. while the overall BP fitting tab restricts the train test split to each dataset. The specific model testing tab offers a more flexible way of data partition. Using the full mode, we can partition datasets to training sets and testing sets, calibrate the model with data merged from all training sets, and test the model on all data merged from the testing sets. On the other hand, if we choose the split mode, then the GUI first individually partition all involved datasets to training and testing sets, then merge all the training sets from the selected training datasets to form the final training set to train the model, and test the model on the merged testing sets from selected testing datasets. This is useful if you want to let data from some subject to present in both the training and the testing set, while mixing it with data from other subjects. Finally, we'll briefly talk about how to expand the PostLab GUI with customized functions. All methods for signal filtering, characteristic points detection, signal quality index calculation, PAT selection, and blood pressure regression that are valuable in the GUI are saved as class definitions in these 5 method folders. The GUI scans and loads methods that are present in these folders at startup. So if you want to use your own function in the GUI, all you need is to implement your own classes with realization of your customized method and add your class definition file to the corresponding method folder. You can check the code of existing methods to get a list of functions that need to be implemented in the class. That's all for today. If you have any question, feel free to email us. Have a nice day.